Hi everyone and welcome back. Welcome to my video, and here we are covering Uber Eats clone. And now what we are going to do is we are going to think about the deployment of our application. So we have microservices, we have the front-end applications. So what all we have? We have microservices, we have front-end applications, and which is having SSR and CSR both. Right, so we need to think about how we can deploy these applications to cloud, maybe AWS, DigitalOcean, or some other platform. I'm targeting only AWS because we can keep all the things on the same stack. So what do we have? This is our front-end applications. These are our, you can say, repository, monorepo. And here we do have our front-end application. We have our microservices, multiple microservices like user service, auth service. Then we have a restaurant service, order service, card service. And then we also have here some front-end application, which is like SSR and CSR. We also need to think about how we deploy it. If you talk about CSR, client-side rendered application like React, what we till now in your projects also you might have heard about, you are rendering through S3, or you might have deployed it to some folder and rendering the content through Nginx, right? Because when you talk about simple React app, what we do is in React app you just create a build and it gives you some folder like dist or build. We just need to serve that be dist or build folder from somewhere so that your client can download the whole code and can run the whole code at the client side. This is what a typical client-side application does. And how we can deploy it, we can either use a simple EC2 instance. Here we can just use EC2 instance, and then we can have a simple Nginx on top of that, and the Nginx will read the content from some particular directory, and that server is already up and running. Nginx is running there, and from here you can actually directly talk to that. It's like that instance is in the in VPC, but you export some particular port like port 80 so that your content can be rendered to the client side. This is typical. Now then we started thinking, okay, this is just like a build folder. Why can't we just deploy it or host it through S3? Why we are having EC2 instance up and running 24/7 for that, right? So what we then thought about, okay, we can have a cloud front. I will talk about these different terms which I'm using here. This is the cloud front, and here you can have a simple S3 bucket. In S3 bucket, whenever you deploy the code, you just sync your content to the S3 bucket, and you actually put a content distribution on top of that cloud front, and you can put a Route 53 or you have your own domain. Then you can render the content, because you need to have some address like tksharma.com, my website, right? So Route 53 will provide you the domain. You will go actually from this path. Okay, so you will use this path Route 53. If you don't have any domain, registered domain like your website.com, it will use CloudFront, and you will be able to access the code from the S3. So whatever your dist and build folder, right, what you are doing is you are just synchronizing your build folder to S3 bucket. And might be for some of the people these terms are totally new, but you will get familiar with all of these things. So it's the front end app. But when it comes to server-side rendered application like Next.js and SvelteKit, they are not like some build folder. You need a server to run them. So there are multiple options available to deploy them. I mean, you can also deploy this CSR application through the Netlify, through the Vercel, or any other platform which is available, providing these things publicly. Okay. So what we can do is, if you have a Netlify account, just simply create a Netlify app, and it's very easy to do these things on the Netlify. Okay, Netlify, you just need to configure the app, provide your GitHub locations. Currently it's monorepo, so we need to also see the setup if you want to deploy it to Netlify. That's totally different setup, because it's a monorepo and you have to expose only particular folder to the Netlify app. For the client-side rendered application, Netlify setup is easy. Even for the server-side rendered application, the setup is easy. I think for the when you are deploying a SSR app, you have to pay something. You have to add your card because there is a billing associated with that. So that's little different. But yeah, setup is just like, okay, filling the form. What are the commands? From which particular folder you need to pick the build folder. These are the simple instructions you provide, and it is fine. We can talk about this just for your knowledge, like how we deploy it through the Netlify or Vercel, the CSR and SSR applications. But to keep this stack same, we will be using CloudFront and S3 for the CSR, and for the SSR we can use a Cloud Edge function, okay, Lambda Edge function to deploy your SvelteKit or Next.js. We will try the Next.js and then we will see. Okay, these are your microservices. MS1, microservice 2, how we deploy them. Currently these are exposing REST interface, right? REST interface. And what is the easiest stack which is available right now? We can just go with the serverless stuff because we don't need this application to be running and I'm getting charged for the billing. What we can do is we can use a Lambda here, Lambda serverless stack actually, we can say. And we can explore Lambda API Gateway. We use a Postgres for some of the services. We can think of using DynamoDB. This stack is pretty much similar, and we can bootstrap all those things through the AWS CDK. So our stack may be simple, may be complex, that is a different thing. But why we are talking all these things? We are going to dive into the AWS world, and we are going to explore a lot of things, the different components like CloudFront, S3, AWS CDK, how to actually access the AWS platform. AWS provides, AWS is a cloud vendor, right? How you can access the AWS. You might have done that in the past, like this is you sitting here and you wanted to access AWS. What all different options you have? You actually have a root access, you create an administrator user and you use UI console, like dev console. Or you are good at AWS CLI, from command line you wanted to create a resources, or you can use AWS CDK. I mean, there are many options to create or access the AWS resources. AWS CloudFormation, but for that again you need to have an AWS CLI. But these are many different ways in which you can access the AWS resources. When you are learning AWS from the beginner, what you do is you create your account and you start using through the AWS Dev UI console. It's like a user interface where you click on some buttons and everything gets popped up. You will be able to create resources like S3 bucket, EC2 instance, CloudFormation, or SNS, SQS, Lambda, anything you can create through the UI console. But here we want to do things programmatically because I'm a developer, I'm not a DevOps person or ops person. What I want you to enable is you should also be able to write code or write the AWS stack. Earlier, there was a concept of AWS CloudFormation, and you can write a CloudFormation template and you deploy it through the CLI. I didn't like it because there you need to write a long, big JSON objects stack, and I quite not much into CloudFormation. Then they introduced AWS CDK. What it does is you are writing TypeScript code. That's awesome, right? You are writing just TypeScript, React TypeScript, or Node.js TypeScript for writing your application. Now you can use the same technology, same stack to create your S3 bucket, EC2 instance, and all these things. So I'm a developer, I can write front end, back end, and also I can write my operations like DevOps stuff. I can build my CI/CD, I can deploy my front end app by building a CI/CD and then deploying it to S3. So this couple of videos in coming series is going to enable you to understand AWS and how you can access through the AWS CDK. CDK is a cloud development kit. Using that, you will just write a code and just you need to have AWS access key and secret key, and then just run the code. AWS CDK deploy like npm script package.json script, and you'll be able to create anything you want. So on the same line, I'm going to talk about this thing. This is a slides provided by AWS only. It's not mine. I don't have a copyright for this. So what we are going to talk about is how these things really happens. So initially you might think, okay, I'm not able to understand these things, what is going on. But when we really sit together and write code, and I will try to create, okay, this is how the things are getting created on AWS, then you will understand more. AWS CDK is a platform which is having these different building blocks, which has a stack has a constructs. So every AWS components can be created using constructs like S3, SQS, SNS, EC2, CloudFront, S3, or any component, you just name it. Every component can be constructed using construct. Construct is nothing but a class. And whatever the resources you wanted to create, that can be added inside a stack. So like I'm creating a simple stack where I'm going to write a simple API, REST API, which is going to consume through API gateway and going to hit Lambda, right? Simple. I can just create a simple stack. Stack will contain all those things together, and then that is your AWS CDK. What actually it does, it helps you to build all these things either using Python, Node.js, Java, JavaScript. Simple, right? You are writing a code to create your infrastructure. And I really like it because earlier I didn't like CloudFormation. I used to try to learn it as a developer, but I really hate it. Then this AWS CDK came into picture, and I'm just writing a plain classes that is giving me everything I need. I'm just creating a simple class. When I deploy it, S3 bucket is created, EC2 instance is created, and I really like it. And that's why I'm going to introduce this in this playlist, because learning this empowers you to explore other things outside your front end, back end, mean stack, mun stack. Oh, forget about it. Focus on the overall development. Okay. So what we are doing is, this is just a CDK reference. You can create any resource with the help of CDK, and it's available in the Python, JavaScript, TypeScript, .NET. What we are doing, forget about this example. What we are actually going to do in the real world, we have a front-end application, React app, which we are going to build fully, that will have a Uber Eats landing page, or maybe some components, the whole front-end application with all the routes. We are going to deploy it to S3. So what all things we need? We might need a CloudFront, S3 bucket, and all these things, right? So all those things you can create through this CDK, and you just use this CDK CLI. So what you do is, here you will just install AWS CDK, then you just do CDK init language, TypeScript, and then you will write some code. When you execute it, it synthesizes the construct and your stack, and it creates an AWS CloudFormation JSON. So you don't need to worry about generating a CloudFormation template. And then when you do CDK deploy, it deploys your CloudFormation, because AWS understands CloudFormation only, not your TypeScript or JavaScript or Python code. There is a compiler which is synthesizing it and generating a CloudFormation template for you, that is JSON or YAML language, which AWS understand, because there is a AWS CloudFormation already a component in AWS which is heavily used, that gives you can say context to AWS. Okay, what all resources I need to create: S3, CloudFront, Route 53, API Gateway, Lambda, DynamoDB, EC2 instance. That CloudFormation will be executed by AWS, and AWS will create a resources based on your AWS account, AWS region, maybe a VPC, subnet, all those information you will feed in through your code. But what you are familiar with, only your code. This is my stack, and these are the resources I wanted to create. Why this is important to understand is, we are going to write code to create the infrastructure. And my objective to talk about this is, next I'm going to put in a AWS CDK workshop. So developers who are writing front and back end can also understand how to deploy, how to create AWS resources through AWS CDK. I'm using it from a couple of years now. I want to put a content, and I wanted to use Uber Eats clone or any other full stack clone application to be deployed through the AWS CDK. So developers will understand, okay, yes, this is how it can be done without a DevOps. Okay. So this is our next plan. I will also attach this slides provided by AWS in the description, and we can dive in. So we already have our Next.js admin dashboard ready, and the front end React app is ready. We will just play around and we will try to deploy that through this AWS CDK. First, we will understand AWS CDK, what it is. Then we will pull in our microservices and front end and client side rendered and server side rendered app to deploy it. So we are going to explore a lot of things on AWS, and it's going to be fun. It's not about, this whole playlist is not about writing a just simple UI and doing a API integration. Hi everyone, and welcome back. Welcome to my another video, and in this video we are going to deep dive into some AWS stuff. This video is a part of Uber Eats clone, and we are planning to build the infrastructure through AWS CDK. So in the last video I talked about what is AWS CDK and how this AWS CDK can help developers to build the infrastructure on AWS, either deploying a microservice or either deploying a front-end app, which is just a plain React app, or another application like server-side rendered application to a Lambda edge function. So these are all the aspects we are going to explore through this AWS CDK workshop. CDK is a cloud development kit provided by AWS to the developers, so they can write their code and can deploy the application by creating the stack and the constructs. So this is my root account. I mean, I'm just showcasing how it really works. You need to have a AWS account, and to access AWS, how you can access AWS through this UI console, the nice and clean UI console, through programmatic access using AWS CLI, or through these AWS CDK kit. What you need is, you need to have access key and the secret key. So you need to keep those keys safe within yourself. Don't share it with anyone, otherwise they can access your AWS console and can create unnecessary resources. Then you will get the billing. That's not good. Okay, so this is my root account. What I will do is, I will sign out root account because I can access the billing. How to check if this is my root account? I always go to the billing and see if I can access the billing section. Yes, then this is my root account, and I can access my IAM, identity access management, and I can see the number of users I have in my account, and I can also check the security of my account. MFA is enabled. This is the root user, and I have only one user, so I will just do the logout and try to log in with that. Sign into the console, and here I will just use IAM user. Okay, this is also MFA enabled, even the administrator account. This is like there is a root account, and then I have created another administrator user, so I always use this administrator user to access my account. And here we are able to log in. After doing a couple of demos, I will remove this user because I'm exposing a lot of my information through this account. So this is my administrator account, and here I can not be able to see the billing console. Let's see, and then we will just explore a little bit about all the AWS services like IAM. IAM is identity and access management. You can actually manage the number of users. Currently I do have only one user. We'll create one sandbox user, and we will play with that sandbox user. We'll just give a couple of permissions. So I'm not going to talk about the basic fundamentals, okay, how to work with the AWS console. There are thousands of the videos already available. You can just play with them. Or you can just create a new user, add it to the role group, and all those things you can do. So currently we don't have any role group. I can create a simple role group, sandbox users, and I will also add this TK Sharma to that user, and I can attach a policy, administrator access. So here I will give administrator access, that is like a full access on AWS console. So I'm just creating this group, and now you can onboard any other users if you want. I already have this user. If you want to just create you can create a new users here, and then so here I am users. You can create another user, let's say TKS Sharma sandbox. And then, okay, custom password, auto-generated password, that's fine. Next. So the sandbox user, and this is the permission boundary. So in the permission boundary, I can just give administrator access. Next. And I just do a create user. So now I do have two different users. You can see TK, Sharma and all. And now with the help of these users, what you can do is you can actually create a access key and a secret key. These are the security credentials which we are going to use. Here we will just create an access key, because to access the AWS console, what you need, access key and the secret key, and this is how we will do it. So access key best practices, what all you wanted to do with that, you are planned to use through the command line just for local code and all. I will be using it for the command line, and you just choose other tag value. Okay, AWS access. I mean, this console always gets changed. I will say done. You need to download these access key and secret key, otherwise they will be lost. And what I will do is, so this is just a simple plug and play. I will just delete both the users. At least I will delete this one. So this is how you can create the users on your AWS console. And now we can also talk about all the services. So I will be deleting that user because I have exposed some credentials. Even I will delete this user also. So what we are doing here is we created a user group, roles, policies and all those things. If you look at the AWS services which we are going to explore, if I talk in terms of this, what all services we need to access all these things. And what we want to do is we want to deploy our applications. So what all AWS components which we may need is, first of all, I mean, we may need a lot of things, but S3, CloudFront, we will need Lambda, API Gateway, and maybe a DynamoDB and RDS. And obviously I am creating all the users to access these resources. IAM policies, roles and all, and then we will access all these resources. So let's come back to here and we can explore all those things. So this is S3 bucket. To create S3 bucket, we can deploy our simply CSR application, client-side rendered application. Let's say I wanted to just build a simple bucket and I can host my application from there by enabling the static website hosting. Then you need to have us create a CDN using CloudFront. So we have these CloudFront. CloudFront will enable a CDN on all the edge locations we have. Like there are multiple edge locations spread around all the planet provided by AWS. So there will be a caching enabled on all the edge locations. So whatever the content you are rendered from this, like your static website or any of your front-end website, that will be cached and can be fetched very fast. And then we will talk about the Lambda. Lambda is actually just a functional based. You just write your functions. It's like no serverless. We will talk about the serverless aspect, which covers the Lambda, DynamoDB, API Gateway, and all those serverless technology we are going to talk about. Here you just write a plain simple Lambda functions, and those Lambda functions are nothing but JavaScript, TypeScript functions, and they will be able to execute your code when you trigger it through the API Gateway. So we will be thinking about deploying our microservices as a Lambda, Nest.js microservices as a Lambda. So it's all together exploring a lot of new things on top of that. And then API Gateway, because you cannot hit the Lambda directly from the outside world. you need to have an API gateway which will expose the execution of a Lambda. So you will hit an API gateway method, get, put, post, delete, patch, and then API gateway will indirectly hit your Lambda or any other AWS resources. And you can also talk about DynamoDB. Let's say DynamoDB. If you wanted to use DynamoDB as your database, then DynamoDB provides a very nice performance. You can create a tables. These are like key value pair database, no SQL database, and it is very nice to have. We just need to have a partition key and sort key, and you can have a database tables. It's not a database, you just need to create a tables, and in this particular region you can create multiple tables. There is no concept of having a database in the DynamoDB. We will talk about that. And what else we have? CloudFormation. Through the AWS CDK, whenever we are doing AWS CDK synth, your stack actually converted into a CloudFormation template, and then that template will be populated inside your AWS, and it will create all the resources. So once we do AWS CDK deploy, we will see what CloudFormation template has been generated and what all resources has been created for that. So a lot of things to explore. Actually, CloudWatch we will use to see the logs. So all these are actually the developer tools or developer components we are talking about: CloudWatch, CloudTrail. If you talk about, you can actually look into a basic fundamental thing about AWS, what all components are. These AWS components are divided into the different sections like compute, storage. In storage, we may use RDS, relational database, and we can just use some RDS instance to connect to our Node.js services, and we can store our some of the tables there. So database, compute, AR/VR, analytics, all these are the different sections in which all these are divided. Like if you talk about compute, these are the compute which contains EC2, Elastic Beanstalk, Lambda and all, which is talking about execution and processing. When we talk about the database, it's all about storage, what all different ways in which we can store our data using RDS, using Elastic Cache, DynamoDB and all. Then we have a container solutions, ECS, Kubernetes and all. Analytics, how we can do analytics of the data, cloud search. And then we have cost management, which is talking about the billing, cost explorer and all. Developer tools, these are all the tools which you can use to like creating a repository, building the pipeline, code commit, code build, code pipeline. This I used to, I worked on them, but here we will be using GitHub and GitHub CI, GitHub Actions to deploy our application. And this is pretty much, I mean, you can explore all these once you have an account. For the storage, there are like, this is the real storage which talks about storing data in the S3, Glacier or Elastic File System, AWS backups, all these components. If you talk about the tabular or SQL databases, then these are the different storage medium in terms of the different databases. Okay, like Amazon Aurora, which is also popular, we can think of using it, but we will be stick to the RDS Postgres, and this is how we are going to work on it. So let's not delay our stuff. What you need to have a AWS console, and you need to have one administrator user, MFA enabled on the root account and the another administrator user. MFA should be enabled on both, and you should be accessing the AWS console using your administrator user. But before that, what I'm going to do is, I'm not going to use the administrator user access key and secret key, which are same every time. Instead of that, what we can do is, I'm thinking to create AWS organizations. So let's say this is our AWS console, and AWS organizations helps us to organize our stuff inside multiple accounts. Let's say in big organizations, what they can have is they can have a billing account, they can have a finance account, a developer accounts, where they are actually working on the applications. So here I wanted to just orchestrate and make you familiar with this. So we'll create a multiple AWS account, at least the dev and the production. And on dev account, and we can just log in through the SSO, and we can get the access key and the secret key and the token, and using that we will be accessing the AWS resources. This is how we are going to go forward. So first we will explore AWS organizations. What we need, first of all, we need some mechanism to access AWS services. For that we need a AWS access key and a secret key. Either you can just go to your IAM and create a new access key and secret key and just download it and keep using it. But I wanted to use it in the different way. We will create AWS organizations, and from there you can create your AWS access key and a secret key for a particular organization. That keeps changing because it expires, so we will be safe on that side. So stay tuned and let's see that in the next video, AWS organizations. Hi everyone and welcome back. So in this video we are going to bootstrap our stuff for the AWS CDK and how that is going to help us to deploy our infrastructure for Uber Eats clone. Okay, so what do we have here? If you see, we have the simple AWS. We have AWS account already available that you need to create if you don't have, because we are playing with the AWS, so without account we cannot do anything. So if we talk about simply, this is, let's say this is you as a user and how you can interact with AWS. This is, let's say, user who is trying to use the resources from AWS. There are many ways. I mean, first of all, you can just use CLI and you can just use the UI console. But that's like you manually type the commands or you access the UI console. So this is CLI and this is UI console. But what are the other frameworks which are available which does this all the automation for you? Let's say I wanted to create any resources, or I wanted to deploy the applications or a particular stack. There are many frameworks available. You can use a serverless. This is actually a framework which is more into serverless, but this is on the same line that you want to deploy your app, you want to deploy your APIs, you can use a serverless framework. This is like a third-party vendor tool. Using this, you can deploy your application. Or you can use AWS CDK that we are talking about. That's provided by AWS only. It's just like some AWS CDK is a library which is available in the TypeScript, Java, Python and all, and you can just use that to deploy your application there. And all these things, I mean, if you talk about the serverless, AWS CDK, they all use a CloudFormation to create the resources on AWS. So CloudFormation is nothing but an AWS component. So this is like CloudFormation. It gets all the instructions, what needs to be created on AWS. These resources can be inside a VPC, I mean, obviously inside a region. So when you create an account, you will get a region, and inside region you can also create a VPCs. But most of the resources like S3 bucket and CloudFront and all, those are not VPC agnostic. Like if you are creating a EC2 instance, then obviously it needs to be inside the VPC, virtual private cloud. VPC is a component of AWS, CloudFormation, VPC and all. So AWS knows how to do it, and we are just writing a code for it. So what in the prerequisites, what all things you need is, you need a AWS CLI. I will talk about it, like how you can install it. A simple AWS account, Node.js, IDE, AWS CDK toolkit, that's a NPM module, and we can get started with the simple TypeScript based project, which is using AWS CDK and all. So I'm using Mac. This is just a simple AWS CLI bundler. And how you can check that you have AWS already there on your system. You can go to the terminal and type AWS command. If you have AWS CLI, that's it. I do have AWS CLI, that's why I'm able to see this command help and all. Okay, so that's, you need to have AWS CLI, you need to have AWS account. That's the important part. You need to have AWS account with one administrator user. I already have shown my AWS account, and we will create a simple CDK workspace sandbox. I mean, I have already shown you my AWS account, and we are going to create a one administrator user, and we'll just create a role group and basic simple user with the name of CDK user. which is going to have administrator level permissions, and then we are going to use the access key and the secret key to configure the AWS. So how we do it simply is AWS configure. What it is about, I mean, if you already know, you can skip this part. AWS configure means when you are executing commands from your terminal, how AWS knows that what is the user, what is the region you are executing, and who is the user. And the user identification is happening with the access key ID and the secret key that you are going to get after creating a user. Because you are accessing you will still access the command line. You are just using the Node.js command npm run deploy. But Node.js internally use your AWS profile to understand in which region, in which account, and who is the user deploying the application to the AWS. Without these credentials, which belongs to the user, you cannot really access the AWS resources. That's a prerequisite. So what all prerequisites we talked about? AWS account and administrator user, Node.js, CLI, which needs to be there, VS Code and AWS CDK toolkit. We can just do a simple npm install -z AWS CDK, which we can install. I mean, currently my node version is 16.18.0. I may be already having the AWS CDK. So AWS CDK provides all the commands which we can use to ZSH. I mean, I need to configure it in this so I can access it. So AWS CDK command provide us a mechanism to create a simple applications. Let's say I'm just choosing a simple TypeScript. TypeScript workshop, and I will just use a CDK init command. So this is CDK. I forgot that. CDK command gives me all the options. So it will ask you like, what do you want? CDK init app. If you want to create simple applications, then you can create it like this. So I'm going to focus more on the JavaScript, TypeScript. So we will use the language CDK init app, and what is your language you are choosing, because the CDK library is available in all these things, and you can write your CDK infrastructure as a code using all these languages and technologies. Oh, that's good. That's good thing. Sample app, lib or app we can create. What we are going to do is, this is my repository. If you look at, we'll talk about it. So this is our workshop, AWS CDK workshop, and we are going to just create these simple packages. One package will be just creating S3 bucket, one package creating EC2 instance, one package will create a SNS S3 and all. And how this is going to be used in our Uber Eats clone is, we are going to create an infra folder for each and every service and each and every front-end app. An infra folder will have all the required TypeScript code, which will help us to deploy that application or that resource to the AWS. First, we will play a little bit with the AWS CDK workshop. Here we will understand some stuff, and then all these things will be utilized in Uber Eats clone app. So coming back here, this is the repository we have. I will go to the code again. So here we are going to use AWS CDK. This is the toolkit, and we already know what all things we need. So just create a simple profile, you need to have an AWS account, just create an administrator user and get ready with the rock and roll. So here I will just go to this repository. What do I have currently here? I will just show this in the VS Code also, but it's just a simple npm workspace which is having nx. Nx is the monorepo. If you talk about the code, inside these packages we will be adding, what are the common resources we are going to need: CDK S3 bucket, CDK SNS, CDK SQS, or CDK Lambda, CDK Dynamo, CDK Postgres. All these artifacts I'm going to create here, folders I'm going to create here, and then we will use these CDK commands to create these resources, like a simple S3 bucket which I want to create. So I should be able to do it using this. So what I will do is I will go to the packages and I will just go npm run deploy command here, npm, which is going to use CDK and will create S3 bucket for us. So this is just like a prerequisites, the preparation phase, you can say. These are all preparations we are doing, and this is the annex. So let me clone this and I will just open this for us. So I'm cloning this and I will open this in the VS Code. Okay, nice and clean. These are my packages, and what do I have? Simple npm workspace. Here you can see the workspace. Why? Because I'm using the packages. This is the npm workspace. You can use the pnpm workspace and add annex on top of that, or you can use the yarn workspace, add annex on top of that. This is just a simple npm workspace, and we are going to add things inside of packages. So if you just do a simple command to create a new package, how you do it? So cdk packages, and we already know the command. CDK cd demo app, and we can just run this command. Okay, so it will give us simple TypeScript skeleton project. CDK init app. This is the demo app. So why I want to do it? Because I don't want to write all these packages and tsconfig. I mean, it just every CLI tool provides these generators which are helpful for bootstrapping a simple application. So it's not an application here, it is giving us a simple setup which we can use to deploy the resources to AWS. So let's see this. Inside bin we have a demo of TS. So it's like a simple demo stack. Inside this stack it will have a constructs. So in the first video I talked about the stack and the constructs. These like SQS, SNS, S3, EC2, CloudFront, all these are constructs which we are going to create. Construct means resources, and they will get added to a particular stack. Like I'm creating a simple stack for my front-end app. So stack can be a dashboard UI stack. Dashboard UI stack can have your S3, CloudFront, Route 53, all these are the constructs for it. So you can see simply here is nothing much. Package JSON, it has the dependency of AWS CDK-lib, and all this is given to us. And this is CDK JSON, and this is simple setup. Now to deploy this, currently it doesn't contain anything. We can just talk about CDK init and the basic command CDK synth. So if I just go to package JSON, first of all I will go to the root. And we can just do npm install. And then we can just run couple of commands onto this package, npm run build and all. So you can say there is a CDK command also there. Packages demo app npm run build. What it will do, it will just simply build this project. We have all the dependencies, tests. Okay, it should be commented because we don't have any tests yet. If you want to use test, then all the testing libraries should be there. So let's keep it commented. So it is just doing a simple build, and npm run, if I just do, there is a script npm run CDK. Why I use this types? So we are going to add these commands CDK in deploy. So let's say if I just do a CDK deploy, it won't work. I'm just showing it because you need to provide your stack name and all to deploy the CDK. So CDK deploy, it will check prerequisites. Now we didn't specify the stack and the environment, and nothing has been specified. nothing has been configured. So what we will do is unable to resolve AWS account to use, it must be either configured. First of all, AWS account, then you need to provide a stack name which you want to deploy, otherwise it won't work. So let's so this is just a simple basic setup. What you need to do is just do a git clone this repository, and then we will start doing a preparation. I will also create my admin user and configure my AWS. So simply AWS configure, provide your AWS key, access key and secret key, and the reason in which your account is created, reason in which you want to create the resources, and the admin user. Okay, let's see that in the next video. So what we are doing is, here you can see we have a user group, sandbox users, that has permissions of administrator access. We are just going to add a user. This CDK user I have added. This is also having now administrator access and IAM user change password access. We need to worry about administrator access, which it is there. MFA for now we can leave it, and security credentials we can generate access key, and then we will delete it. So this is going to use, let's say, other, create access key and secret key. So we got both of these things. We will configure it in our AWS CLI, and we will be just done with this. We can also download it. I have downloaded it, done. So I can see I have a user group, and this user has been created that has an access to administrator account. So what I will do is I will log in with this account. Here you will see access key ID, and this is the ARN, and how you can log in. So this user has been created. This is the console sign in link. You can use it. We already have created access key and secret key. For this, I can use this console sign in link. So this is using this is going to log in the TK Sharma. CDK username is CDK user, and the password, remember. And I can access my account now. So what we need to do here is, I already have access key and secret key downloaded. I will do the AWS configure, and we are going to access this US East 1 region. There are like multiple regions are there on the global scale. So we are going to use US East 1 region, and we are going to create a resources here. So let's do AWS configure. And here we have access key ID, and we got secret key, enter, and the use default region is US East 1. So our basic CLI setup is done. Now what we need to do is, we can just start playing with the CDK commands. Workshop link, and here we have these simple commands. CDK init to just create a bootstrap a simple project for the TypeScript, and then CDK synth command. It synthesizes your platform like you have written some code, but AWS doesn't understand your code. What it will do is, using CDK CLI, we are executing this CDK synth command. What it will do is, it will just generate the CloudFormation template for you, like based on the resources you have written inside your AWS, inside your code. Currently we are not adding anything. Let's see, let's create a real stack. Here is our app, and here we need to specify the environment also. Inside the stack, let's enable these things. So here it is just like creating a simple SQS queue. Okay, now if you just do a simple synth again, it is using CDK synth command. You can have a different command in your package.json. So now it will have those instructions to create the resources. Okay, so what I will do is CDK JSON, and here you will see CDK out. These are the artifacts has been created. These are formally called CloudFormation artifacts. This is a JSON file. These are the assets which we are planning to create. This is a simple template. Okay, so we need to specify the environment to this. I mean, we need to specify on which environment you are creating this resources. So CDK default account, either you just populate these variables through the env, or just put here export CDK default account and your account ID, some numeric, okay, and CDK default region, export CDK default region, and you will just specify US East 1, okay, and then we will just, so this is how you can just pass the environment is just like a numeric key and your region. So I mean, before we deploy CDK synth and deploy, we need to know, okay, in which environment and which region we are going to deploy the application. So we need to have the information about CDK account. So let's go to our AWS console. So let's add all these commands first. So we won't need to execute these. CDK, let's say bootstrap. So CDK bootstrap is the command which will initialize your account. CDK synth and CDK deploy. These are like simple scripts I have created. Now, how can you get your account? So if you go here, you can get IAM user and account ID. This is your account ID which you are going to access. So my CDK default account is this, and my CDK default region is this. Okay, now I can just do npm run CDK bootstrap. So what it will do is, it is executing CDK bootstrap command. It is bootstrapping this account. It is just preparing this so that we can create the resources. So we already have administrator permission. Let's see how it goes. CDK toolkit, creating a CloudFormation change set. So till now we are going step by step on creating the resources, and it is just going to initialize the account and then just will allow us to create the resources using CloudFormation. So CDK toolkit, and we won't see much changes in the code. It is just executing this. So we have to wait for some time. Okay, and we can see this environment has been bootstrapped. This is the first step. We need to do CDK bootstrap, and now you can do CDK synth, npm run CDK synthesize. This is called synthesize. Okay, for now I'll just try to do deploy and see what do I have in the stack. Let's see, I have created simple. So this is my stack, and I do have a queue construct. This is the resources which I'm thinking to create. So let's see how it goes. So it's building the assets. So first of all, it initializes the environment using CDK bootstrap, and it has to create a couple of resources for it. Now this is my stack name, demo app stack. This is the inside this you are passing the name of the stack. So you will see the same stack name on the CloudFormation on the AWS console. So this is the demo app stack, and we are passing the account, region, and what this stack contain. Stack contains only a single construct, SQS Queue. Here you can create S3, whatever the resources you wanted to do. All those things we should be able to put here. Now what you would see on the console, what is happening, it is creating these resources using CloudFormation. So here we will go CloudFormation, and you will see some activity happening on the AWS because this CDK deploy command is creating the stack for us. First of all, it did CDK toolkit. CDK toolkit is required to bootstrap your environment. So once you do CDK bootstrap, it creates this CDK toolkit. It's like a default stack which needs to be there so that we can execute a CDK commands. And now it is creating this, and you can see the resources, what it is creating, demo app, SQS Queue, and all these events like what create is in progress, what actually it is creating. We could have given a proper name. It is actually creating SQS Queue here. This is the type of the resource, and this is the resource. So this is like a create in progress. It will take some time because we are creating SQS Queue. It can be simple S3 bucket or EC2 instance for EC2 instance, you also need to bootstrap. Okay, you need to provide the input for which VPC in which you are going to create a EC2 instance. But for simple S3 bucket, because you wanted to host your front-end applications, so you can just provide a simple S3 bucket configuration. So these are called constructs which you are getting from AWS CDK toolkit, CDK-lib. These are the constructs. So we are just creating the simple class. This is the stack name, and it is extending the CDK stack. And here we are passing the props. So here we are passing, then we are getting the environment, and we are getting all the props from this. So here we can extend these props, and we can pass anything because it's just a class we are calling. And then inside this stack we can just decide, okay, what needs to be done with all these props. But here you need to call the super class constructor for the CDK stack, and then now you create your constructs. Now if you look at the AWS console, this has been created. We have created an SQS queue. If you look into the events, stack info, this is the stack info. And even if you go to SQS, forget about what is SQS, but it has created that kind of a resource by just what we did is we just created added 2 lines of code, and it has created this stack, this SQS queue. SQS queue is used for messaging, for asynchronous event driven approach. When you want to allow 2 services to communicate with one another, you send a message to the queue, and then there is a listener service which will listen to this SQS queue. Let's not go into that detail because we are not targeting that. Here we are able to create a CloudFormation. So what these commands, basic commands we executed. So if you look into the package.json, CDK bootstrap to bootstrap the account, CDK synth, and CDK deploy. Now I don't want to keep it for longer. I will just remove this queue stack from here. Let's see what happens. It should be able to purge these resources which has been created. So I will just do CDK deploy. It will see now the change. What you have created a change in the code. You have removed this queue, right? So it will just create this local assets, and then it will send it to the CloudFormation, checking what has been changed. You can delete the resource, you can update the resource, you can create the resource, and we can see delete in progress. And manually we can also delete this stack. I think there is a command CDK destroy, that also we can use. So it will just clean up the resources has been created by that stack. CloudFormation stack, and you can see the CloudFormation push has started. If we just see this update in progress, and what it is updating, it should be deleting a resource based on, yeah, you can see delete in progress. So what it is deleting the SQS queue which we created because I commented those lines of code. So it will delete that stack now for me. You can see delete in progress. So I mean, this is really how you are going to play with AWS through the code. I need SQS, SNS, simple Lambda, for using which I'm going to deploy my simple Nest.js service, simple S3 bucket, and CloudFormation, using which I'm going to deploy my React app. This is how you are going to play, and in parallel to your source code, you are going to create these stack. I'm a small simple application which contains your stack. Here I will just provide some better names, and this stack will use these constructs to create AWS resources. And I think there is a CDK destroy command is also there that should delete the resources. This is a deploy. I will talk about it. Do we have something like that? Okay, this is doing a cleanup. Delete the sample code. I mean, if you just delete it, what it will do is it will just clean up the resources. Your resources will be deleted. So what actually we will be doing, this is you writing a code, creating API gateway and Lambda. And you can see our resources deleted. So at least we are not getting billed for anything because queue has been deleted. We are not consuming any particular resources, but this is how you are going to play with. We just have a AWS CLI. We configured our AWS account by using one administrator user because we have the access key and the secret key. And then we are just executing these simple commands, and we just generated this TypeScript template, SNS or any AWS resources. For that we will just use the documentation, create the constructs, and this is how we will go further. So I hope this is helpful, how we were able to bootstrap a simple project and create a resource. Hi everyone, and welcome back. Welcome to the AWS CDK training sessions, and we are talking about what all we can do through the AWS CDK. You can do anything through the AWS CDK because AWS provides a number of components like SQS, SNS, S3, Lambda, CloudFront, Route 53, Elastic Beanstalk, you name it, code commit, code pipelines, everything you can build through the AWS CDK. So what AWS CDK is, just you are writing code and just using AWS CLI and AWS CDK library to just deploy or create the resources on the AWS platform through CloudFormation. So here in simple architecture, you are using S3 bucket, SQS, DynamoDB, Lambda, API Gateway, and AWS Cognito for authentication. Everything can be built through the AWS CDK. So what is CDK? CDK is just an app which contains a multiple stacks or a single stack, because in the last demo we were using just a single stack, SQS stack, right? But you can have multiple stack, and stacks will have a constructs. Constructs are just like AWS component, Lambda, API Gateway, DynamoDB, S3 bucket, CloudFront, EC2 instance, VPC, all these are constructs. So you can see app will have a stacks. App can have multiple stacks first of all, or you can have a single stack. That stack will have a constructs like S3 bucket, CloudFront, here KMS, here we are using RDS, KMS, and the construct Lambda. And when you do CDK init, it just gives you simple TypeScript app, and then you just create app and the stacks with the constructs. Then you do CDK synthesize. What it will create is it creates a CloudFormation template, and then you do an CDK deploy. It just push your CloudFormation template stack to the AWS if your AWS credentials are correct, the AWS account, and everything is correct, set up properly. Then it will deploy those resources. And because AWS understand a CloudFormation to create a resources through the programmatically, so that CloudFormation templates will instruct AWS how to create resources, what should be the linking, what are the permissions, what are the roles needs to be created. All these things happens on the fly. So this AWS stack you can create either in the TypeScript, either in Python, Ruby, Java. There are multiple language supports, and we are creating constructs. So let's say if I want to have a simple REST APIs, I need a API gateway, I need a Lambda, I may need a DynamoDB, and I may need a S3 bucket. So there may be 4 constructs inside this REST API stack, which is inside a REST API app. You write it in one of the languages, use CDK CLI and AWS CLI to configure your AWS profile, do CDK synth, CDK deploy, and it will create a CloudFormation template, and it will create these resources on AWS. So what is this app? App can have multiple stacks, right? And those stacks are having constructs. Constructs are nothing but, if you look into AWS CDK documentation, these are just classes like S3 bucket, CloudFront, Lambda, all these are classes, and you need to create a constructor, like just invoke those classes like new class name, that will create a construct. So these are construct: EC2 instance, Lambda, Dynamo table, simple endpoint, API gateway, bucket. And how we are creating constructs? Just by using the new keyword, new s3.bucket. If you write this inside your stack, what it will do? It will create a simple bucket. You can specify n number of settings, parameters, which will just check, okay, is it a public S3 bucket? Are you allowing a public access? Is it a static web hosting enabled? All these settings you can specify while creating the S3 bucket. So whatever you are doing manually through the AWS console, that can be done by just these programmatic codes. So what we do is we create app equal to new app, and then we create these stacks. Till now we just created only single app with one stack, and this stack is nothing but inside this you create your constructs like SQS, SNS, anything. So what is our target? Our target is to have the Uber Eats clone app deployed to AWS. So we will create these infra folders for each and every component, like SvelteKit app, front-end app, React app, Next.js app, and the microservices. And then we will deploy them. So CDK, we can use these different stacks, like okay, every app will have its own stack, but in this example, let's say front end stack that contains CloudFront, Route 53 and S3 bucket, and the backend stack which is API stack, which will have API gateway, Lambda, DynamoDB, S3 or whatever is needed for that. So this is how we deploy a simple front end client-side rendered application. Any CSR app. So we use Route 53 if you want to have a domain on AWS. Otherwise, you need a CloudFront, you need S3 bucket, and secret manager on which we need for the CloudFront to provide a certificate. Okay, now I mean these are just like many different examples we can talk and understand. So front end stack is just a S3 bucket with a static web hosting enabled. That should be enough. Or you can also add a CDN CloudFront to get an advantage of edge locations and caching. Otherwise, your API gateway stack, you have API gateway and authorizer, your Lambda stack which contains a Lambda and DynamoDB, and your database stack which will have a DynamoDB, right? And you need to have a proper permissions. Okay, this Lambda can write to this DynamoDB. All these we are going to specify in this CDK. So you can build any complex architecture of which we are going to deploy to AWS, like serverless architecture or a server based where you are using AWS, EKS or Kubernetes or anything. You can deploy that through the CDK. Okay, like let's say here I have the APIs. So I'm just deploying API gateway and the Lambda. I have a user management users on Cognito. So I'm using Cognito user pool that can be deployed through the CDK. And then simple. This is a S3 bucket, and when you upload to the S3 bucket, there is a listener. There is a trigger on the Lambda trigger has been added. That Lambda trigger will push the messages to the SQS queue. There is a listener Lambda which will read the messages from the SQS and put the messages to the event bridge, and then there is another Lambda which is saving those events to the Aurora. So this is like whatever the complexity, but you can orchestrate the whole infrastructure through the AWS CDK just by writing these construct in the stacks. So here how many stacks you see? One stack which is just spin up the Cognito, another stack which contains the API gateway and Lambda, and third stack combines lots of things because these things are connected. S3 bucket with the Lambda trigger, then SQS will have a Lambda trigger through this Lambda, then there is another Lambda which is listening to the SQS messages, and then this Lambda is writing to the event bridge. All those things are like combined. Now what is our idea? I mean we are not going to just cover any random topics. We will just see few building blocks. Okay, how to create a Lambda, how to create a Lambda where you are just using multiple dependencies. Let's say you are writing a simple function, or you are writing a big application, or you are writing a whole Nest.js application. How to deploy it? We will see Lambda with the API gateway and DynamoDB and the Postgres. We will see how you can deploy your front-end application through S3 bucket and a CloudFront. But before that, we will just try to understand these simple constructs like S3 bucket, SNS, SQS, Lambda triggers, event bridge, simple load balancers, how to just create a simple API gateway and connect it to through simple AWS Lambda. All these simple demo examples on AWS CDK that will help us to understand how to build these stacks, multiple stacks, and then we will just try to spin up. We will use these fundamental principles to deploy our applications to AWS. Everyone, and welcome back. So in this video, let's see our overall architecture through this diagram. So we are going to use AWS CDK, and our stack is mostly serverless. So that's why we are saying it is a serverless stack, and we are using mostly serverless technologies because all these Nest.js Lambdas which we have written is going to be deployed as a simple Lambda. So we have written a REST APIs, REST interface in this Nest.js services. All those going to be deployed as a single Lambda, and we will see how it can happen. I mean, I was also surprised with that solutions, and I'm going to follow that approach. All these simple services, auth, order, checkout can be a simple single Lambda with a simple API gateway proxying all the requests to the Lambda. So you see in the architecture what all things we are going to have. We have this whole AWS cloud environment, which we are going to bootstrap through the AWS CDK. We have these backend services, and we have these front-end applications. Front-end applications, which is like client side, we have React, SvelteKit, and Next.js. So all these applications are also going to be deployed to the AWS. Let's say the front end React app. Front end React app is just a simple build output which you can just push through this CloudFront, and CloudFront will read the content from the S3 bucket. So you just deploy your build output to the S3 bucket with the static web hosting enabled, and then CloudFront will read it and it will expose that through the CDN. Like Cloudflare, there is a CloudFront from the AWS which provides caching and through to a different edge locations on the planet. And for the services, we can see there is API Gateway and Lambda. So all these interface, all these APIs are REST APIs which we are going to interact through these different clients like end user, desk, restaurant admins, or a delivery person. All these is going to have access to these API gateways. So what all services we have? We have the proxy service, auth service, checkout service, order service, and delivery, notification services, and many other services which we are going to build. You might get confused what all we have as a different API gateways. Okay, just don't get scared. This API gateway is coming with just Lambda, because Lambda cannot be exposed directly. You need to have an API gateway in front of Lambda. Only in that case it becomes your REST API, which you can expose to the outside world. So all these microservices will have an API gateway in front of them. And then we already have this proxy Lambda, right? So what this proxy Lambda is doing, proxy Lambda in the code is routing your request based on the URL pattern to a respective microservice. Let's say the user service, auth service, checkout service, coder service, card service. So the interesting point here is you send a request to this first proxy service. Obviously proxy service is exposed through this gateway. You will send a request to that gateway. Gateway will execute your proxy Lambda, and then proxy Lambda will send a request to your respective microservice, and that microservice is also exposed through another API gateways. Let's say the auth service will have its own API gateway. So API gateway is nothing but just a URL. We are not going to use the features of API gateway which individual API gateway provides. For we are using API gateway just to get an endpoint, you can say. So every service will have its own REST endpoints, REST URL for that environment, and then this proxy Lambda, which is also exposed through the API gateway, will hit through the code to, this will be a plain HTTP call that you are going to make through this proxy Lambda to the respective API gateway. Now you need to manually configure this API gateway URL in the proxy. Okay, the request is coming for API v1 user, take it to the user API gateway. If API v1 order, take it to the order API gateway. If API v1 cart, take it to the cart microservice. So Lambda is doing all these redirection. It's just like a plain HTTP call, and it's purely synchronous communication happening through this Lambda. So we have seen this stack in the local environment. Okay, there is a Lambda, there is a service which is calling other services. That's just a proxy. We could have utilized the AWS API gateway if we use this AWS Cognito or AWS Authorizer, all these features. For now, this is just like a simple architecture and we are fine with that. But you can also access these APIs directly. It's not constrained, okay, only there is a proxy Lambda, proxy API gateway, because it's API gateway and all these APIs are protected through the JWT token. So any user or any client can directly go and talk to the cart service through the cart's API gateway, user service through the user API gateway. Proxy Lambda is just like, I wanted to expose only single endpoint. All the requests will pass through this API gateway, and the Lambda will decide, Lambda code will decide what needs to be done. That's just like a pure synchronous communication happening. But in our code, we can also have asynchronous stuff going on, because it's all in this Uber Eats clone. We can see many use cases where the events are happening all over the system. Order created, delivery confirmed, order cancelled, and lot of delivery notification which comes over the time. like user has checked out the order, user has placed an order, and then doing the payment. So payment acknowledgement and delivery notification going to the user, all those are happening over the time and asynchronously. And we are using this serverless stack, so we can use this event driven capabilities through by introducing SNS, SQS, event bridge, kinesis stream, all those AWS components. Those can be bootstrapped through the AWS CDK. So let's say order created, user has put some items into the cart and said order created and check out and done the payment. So there will be a lot of internal events happening, and these internal microservices can interact and can do a lot of things. So there can be a Lambda as another microservice, will receive the events from these SNS, SQS and event bridge. So let's say you have emitted an event, user created, so you need to want to send an email. So there you will just send that message to the SNS because you want it asynchronous. You can send the email from that same microservice also, but we want to have a decoupled and event driven architecture where everything is happening through the events. There is an event, there is a responder of that event. There is an event is being generated through one service, and there is another decoupled service which is not aware about the source of the event, is handling that event and responding to that. Like let's say user created. So there is SNS topic, you will send a message to the SNS topic, and there is a listener, and there is another Lambda microservice or Lambda simple Lambda function, Lambda handler, because these are handler. Those are handling the messages coming from SQS, SNS or Lambda. These are Lambda triggers, a plain and simple JavaScript functions. It will get the event and it will send a message to the target email ID, or those kind of things can happen over the whole system order created. So you wanted to, there can be another microservice interested in order created events. They will listen to this and they will change the state of the system in the database. Order created, so user will see a different screen, different data, order has been cancelled, or some kind of asynchronous notifications. All those things can happen through this platform using this SQS, SNS, event bridge, kinesis stream. You can create these Lambda triggers. Lambda S3 bucket, you want to crop it and upload, save it again. Lambda with API Gateway, a simple Nest.js microservice, how we can be deployed as a simple. Hi everyone and welcome back. Welcome to our training sessions, and in here we are covering AWS CDK. So in the last video, we were able to create a AWS stack using SQS. Now I'm going to create a couple of more examples to just get our hands dirty with AWS CDK. So I just copied this demo app into some examples. Okay, let's say I will call it as a simple Lambda CDK. Okay, and here we are going to play with Lambda, how it works and all those things. So we are going to change the name of this stack to just simply API Lambda stack. Okay, and here also we can also pass some more attributes. Let's say I'm just passing the stage. Stage means your environment, like dev, production, or any other environment in which you wanted to deploy your Lambda, because there can be multiple environments. And here stage we need to pass in this demo app state tag. So here I will just change the name to Lambda stack. It is CDK prop, so we can define an another interface. Export interface Lambda props, which extends CDK stack props, and here we can pass stage as a string. So this type for this is Lambda props. So Lambda app stack. Okay, and the stack is undefined. This is required. I mean, this should be optional. If stage is not being passed, then we will just use the default stage. And here what we are doing, we are just going to talk about how we can just create a simple lambda. Okay, so what we are doing here is, let's say const simple lambda function equal to new my function. Okay, this is node.js function. I mean, there are many ways to create a lambda. We will also use other different ways of creating this lambda. So this and your function name. So lambda, and here you can pass the stage. Okay, you are passing the stage from this class. So stage can be the lambda. Let's say the API lambda development, API lambda production. And here you can access the stage from the props lambda function. And this is the constructor, right? What it takes, lambda function is node.js function, and then we will pass all the arguments. Okay, now in the arguments, what all it takes? Memory size is, let's say 1024 default, not much. We are not doing any much computation. Timeout cdk dot duration, and duration dot second is 5 seconds. Okay, TypeScript is our good friend, which is telling us, okay, what are the types we need to use. So memory size, timeout, runtime is important because that is telling this lambda, okay, this lambda is going to use the runtime node.js. Okay, and here you can see, you can specify node.js 16. That's good. I mean, we can use node.js 18, and then this is the handler. Okay, so what do I have is, I already have this simple lambda, and the handler name is, the function name is main. So the same I need to specify, because this is the handler which I'm executing. So the handler is simply inside a string, that's a main function. And then entry point. Okay, what is the currently we are not talking about a big lambda which is representing REST APIs and all. It's just like a simple function which is showing simple hello world. Path dot join, and here directory name, and the path of the lambda function. Timeout, runtime, handler, and the entry point. I mean, which file? Here we are just deploying a simple plain lambda function which is just inside of one file. Otherwise, once we have a REST API and whole microservice, we need to upload the whole assets or the zip file, because it's not a single file, and you will be having multiple npm dependencies. So same happens with the Python or any other programming language. Either you write a simple inline, a single file function, or just write a big app and then you just upload a zip. Because when we see the lambda function, either you can just write a manually code or you can upload a zip for that. Okay, so this is our stack, API lambda stack, and then we also can populate this stage environment variable, put stage equal to development. And now this is our simple lambda function. This is just a simple construct. Okay, so we can also see what we are getting. So we can get the lambda function ARN, and we can put that inside a console out. So for now we just do npm run CDK deploy. So as we have changed the folder name, we need to change the definition here also, from demo app to lambda app. Now if I do, because this is CDK JSON auto generated, and your CDK deploy commands will look into this file to deploy your lambda or your particular stack and the constructs. So now I will do npm run CDK deploy. What it will do is, it will execute this command npx ts node prefix, and here you can see inside this bin we have lambda app, API lambda stack, and here we are passing the account and region, and here you need to give permission. to create a service role and the Lambda. And this is just a simple tiny code we have written. This is using AWS Lambda, and this is just sending an event, logging event, and saying okay, successful Lambda invocation. Okay, once it is deployed using CDK deploy, we can also destroy the stack using another simple command, which is npm run cdk destroy. This will remove this particular stack. So currently this stack is in the creation, so we can check this on our browser. So here you can see that we got the Lambda API ARN. Okay, so our Lambda resource has been created, and this is a particular stack. Now you may do some changes on this particular stack and deploy it again. These changes will be reflected. So what we will do for now is cdk destroy. That will just destroy the stack which we have created. This is just a simple Lambda. We will see the different ways to create a Lambda. And here you can see this simple Lambda stack is just using this Node.js function constructs and creating this Lambda. We are passing stage as an environment variable, so you can deploy this application on different environment like development, production, staging, and it is just deploying this simple file. It is asking, do you want to delete this particular stack? I said yes. So it will be just delete in progress. It will first delete this constructs. We have the Lambda function inside it, and then it will delete this particular stack. So all the resources created inside this CloudFormation will be deleted. And whenever you execute these CDK commands, you will see this CDK out file generated, right? This contains all the CloudFormation resources. CDK JSON is just like a local file which is used by CDK commands which we are executing, like what needs to be included, what needs to be excluded when it is deploying your application. Okay, so this is just about simple Lambda function. Now here it's not like a just only one way to create a Lambda. There are other ways, like simply you can just simply say new Lambda function. Okay, we can get Lambda from here, AWS Lambda. So you can just do lambda dot function, and here also you can pass okay, what is the function name? Let's say I'm just passing my function name is API lambda 2, and I can just pass the environment like stage. And here you need to pass the same arguments. Okay, I think it's like memory size 1024, or you can specify the runtime. So I can copy a couple of things from there. Runtime timeout. Okay, maybe something is missing, we will add it. And then the code from where you are going to import the code definition. So it is lambda dot code, I guess, lambda dot code dot from assets, like from which folder, if you're like bundling, then from which folder I can get the code. Path dot join current directory name, and then what is the lambda function name? I mean, directory name is maybe a lambda handler. Okay, so this is how you can also create a lambda. It's just using the Node.js function. This is the CDK toolkit construct which we are getting from. So this is how we are importing in the AWS CDK version 2. This is the lambda function. We are getting lambda, and then we are creating the function. Okay, so deploying this will be a little different. I mean, here you can see it was creating a Docker container, creating the environment, and then trying to deploy this lambda function. So we'll just remove this. So from directory we need to go up, and then there is a source directory we are trying to deploy. Right, so what we will do is npm run cdk deploy. Destroy we have already done. CDK deploy. So what it knows, it's already know that this is the Lambda assets. From this it needs to pick. Okay, we will be using this only to create our Lambda functions and deploy. Node.js function was just for the demo purpose, and here we are passing the stage environment, and you can see this Lambda function name also should be somewhere. Okay, it is still showing undefined. Why? I am passing a stage as a props. So maybe let's see what is our stack. Export.env stage. So export stage development, and I will do deploy again. So this stage is passed as a props. Okay, let's see this now. We should be getting the stage as a development, and the Lambda function name is development. So we are good. So now it is deploying this Lambda function, and then we'll be able to see this Lambda functions on the AWS console, how it really looks like. Currently it's not bundling anything. It's just like a simple Lambda function, which it is getting from the source folder, which is really not the right way. It will just get everything whatever is inside a source folder. But let's say when we are writing a microservice, obviously when we do build, it generates the build output, right? That is a folder, or that is a zip file that we need to upload as assets for the Lambda, because your Lambda function may have some dependencies. Currently it's just like a simple function, but it also depends on AWS Lambda function, and that's an external dependency which we have added for the typings, for the type definitions, right? So let's see how we can bundle this and then upload it to the AWS for the Lambda function. Let's see that in the AWS console how it really. This is how we were able to create our first Lambda. Now we will see another approach to create a Lambda function. Let's say I will call it as a Lambda function 2, and here we are going to use new Lambda dot function. I mean, this is just another way of creating the Lambda function. Instead of using Node.js function, we can also write something like this. So new Lambda functions, and the name of the Lambda function is, let's say, API Lambda 2, and we can pass the stage also. And all our properties. So properties are simple. Here what we are going to do is we are going to get the code from assets folder. I mean, the simple folder is source, from which we are going to get the code, and the function name, whatever you wanted to put, simple API Lambda 2, and the handler. Handler here is index.handler, because index is the file and the function name is the handler. Now this was being done differently. It was creating a Docker container and creating the whole Node.js environment and deploying it. Here we are just passing the source code, to which it will be considered as a Lambda function. So here we cannot write a TypeScript code. If we are writing TypeScript code, then obviously we need to bundle it, and we need to archive it and add all the dependencies and all. So we are just creating a simple function, index.js. This is just our simple Lambda function, nothing much. And here this is what we are going to deploy. So Lambda app stack, this is our first Lambda function, and this is our second Lambda function. And here the handler is index.handler, and it is getting the code from the assets source. Okay, so we need to comment it out because we don't have this TypeScript file right now. So we are not using this particular construct or Node.js function. We just have this simple Lambda function. So I will just export the stage, npm run cdk deploy. So it should be able to deploy my another Lambda function from the source, and inside a source we have just a .js file. If we write a TypeScript file, because then you need to have all the dependencies bundled properly, and then that is like totally a different set of tasks we will do when we write the simple service. Obviously that contains the dependencies, TypeScript code, bundling, and all these things are involved. And what we are going to deploy, once you just simply bundle the node modules, all the dependencies, you get a zip file, and that zip file you deploy as a Lambda. And then you also specify the handler. Okay, inside there is an index file that contains this function name handler. Here also you see inside this index.js, the function name is the handler. So Node.js runtime, the Lambda runtime will know, okay, inside this folder there is index.js, and that contains the handler as a function. And we can see something happening here, like all the Lambda functions will be deployed here. Our function name from this stack is the Lambda node. Okay, Lambda node, and the stack name is API Lambda 2. I mean, this is just a construct name. Okay, fail to create. Lambda name already exists. Okay, let's change it to API Lambda node. And deploy it again. If the resource already exists, it won't create it again here, because we might have changed the function name. So the thing is, if you change this stack name here, the construct name API Lambda 3, and you change and you are not changing the function name, then obviously it will say, okay, with this particular construct the Lambda function already exists. So now I have changed this one and both this one, so it will create this as a fresh Lambda function with this, and it will deploy it. So let's see the output, and then we will test this simple Lambda function. It is a plain and simple Lambda function, just printing some hello world message. Right, this simple Lambda function just returning a JSON object, and you can attach an API gateway to this Lambda function, so you will get this JSON output from some REST API. So we can see some progress happening at the CloudFormation. So we can see this is because it is updating this particular stack, API Lambda stack. So this is our stack name, this is updating it, and these are the constructs. So all the resources, you can see this function name has been created. Now we can go to the Lambda and see API Lambda node, and you can see a simple function has been created on the AWS console, and you can test it also because it's plain JavaScript. We didn't write any TypeScript code, so we were not having any issues with the bundling for now. So this is just a simple Lambda function. Either you can deploy a simple Lambda function using Node.js function, right? Oh, because here we were writing TypeScript code, and obviously then it requires bundling that and compiling, bundling, and then creating the final outcome, and then just uploading that as an archive. So it is totally happening in the different scale. So if you have seen that, because when we were deploying this container, it is creating a Docker container and then doing all these stuff to deploy this particular Lambda resource. But here it is just a plain Lambda function, simple Node.js function we are deploying, so there is no need of containers and all. So Node.js function is just a one way, and the Lambda node function is just another way of creating a Lambda function using AWS CDK. It's just all about playing with Lambda functions, understanding these different settings you can set. Here you can also set the environments. So I mean, the environments are all the environments, runtime environments you want, because there are many attributes in this Lambda function. If you see, if I talk about configurations, like what all environment variables you have, which you want to add in the process.env, which can be helpful at the runtime for the Lambda function, and all the general configurations like timeout, memory, storage, all these you can provide in this constructs. Memory size, environments, in the environments, let's say the stage. Here I can pass this stage whatever I'm getting, so this will get populated in the environments here inside the configurations. Then permissions like, let's say this Lambda function needs to read and write through the to the S3 or SNS or SQS, then you can add permissions to this Lambda resource. So then you will just use this construct dot grant invoke URL, grant permissions. I think there are many things you can just add. Add permission, right? So all these things are there which will add permissions. Like if you want to add event source, if this Lambda is a Lambda trigger, then you can attach a S3 bucket or SQS or SNS as an event source, so that whenever you put something on the S3 bucket, this Lambda automatically gets triggered. Or you can attach an API gateway to this Lambda, so you can expose this Lambda function to the outside world through HTTP mapping, like HTTP get put post on the API gateway endpoint will invoke this particular Lambda. So all those things we will see in the demos first to understand all those concepts. Hi everyone and welcome back. In this video, let's take a look on other constructs also, like having DynamoDB, Lambda, S3 buckets and all together. Okay, so you can create a simple DynamoDB construct, something like this. Just a simple DynamoDB.table, and the table name, let's say we are using users table, users, and you can also specify the stage in which you are creating it. And table name is simply API users. And then it's a DynamoDB table, so you have to specify what is your partition key, what is your sort key, and all those options you can specify in this. Let's say the sort key is created at, sort key, the name is created at, which is of type number, DynamoDB.attribute type.number. Okay, so this is just like a simple table definitions you have created. It's like a DynamoDB. Similarly, you can also create a simple S3 bucket. How we do it? Const user uploads or user artifacts, whatever, new CDK dot, there are many ways to do it, so you can just do AWS S3 dot bucket, or you can import it like this. Import same as the DynamoDB S3, and here it will be AWS it's not completing. It says CDK dot AWS S3. Is it something we have here? It's still thinking. TypeScript is a little slow here. So S3 bucket, and here what we can do is we can just pass this bucket name, let's say user docs, and stage, this is the environment, and then whatever the properties you want to pass for the bucket name is, let's say the bucket name is simply what bucket name you wanted to put, user docs, and then stage, and then retention policy, removal policy is cdk dot destroy removal policy dot retain. Like if you are just doing a CDK destroy, then do you want to retain it or you just wanted to destroy it, like get rid of these resources? So here we are creating this S3 bucket, user upload S3 bucket, and here is, you can say, user dynamo table. Okay, so we have these two resources created. Now how can let's create a simple lambda function, and then we will give permission to this lambda function to read and write to the dynamo or to read and write to the S3 bucket. So const API lambda function, and here also we will use CDK dot lambda CDK dot AWS lambda. So you can access the resources like this also from CDK dot function, and here you need to specify the whole different properties. This your function name, okay, API user stage, this is my function name, and rest all the properties which we can specify. And in the properties it's all about function name. There are many properties. Runtime will be what is CDK dot AWS lambda. Again we need to just look for the whole path. AWS lambda dot runtime dot node 16, memory size 1024, description. What are the other properties? Memory size, log retention is like how long you wanted to retain the log for this. So we will use this everywhere. CDK dot lambda dot, here is retention days. Do we have something properties like this? CDK dot AWS, it should be AWS logs dot retention days, and you can specify, okay, how many days? 5 days. Okay, so you just need to take the help from TypeScript to play around with all these things. And these are the environments we have, and we need to specify the handler. Handler name is, let's say, API lambda handler. This is your function name, and then the code CDK dot AWS lambda dot code dot assets from assets, and here you need to specify the path. I will just specify path dot join from correct dir name. Just go one step back, and then there is maybe a source directory. From there you can get the index.js. I think we already have something, index.js. We are not writing TypeScript because it requires bundling and a lot of other things. So this is simple code. Environment is, you can pass the bucket name, dynamo tables and all. Current directory name, I think we don't need this thing. We will see. So this is API user. What we will do is, now we have created this lambda function. So API lambda function dot grant write. Okay, or let's say this is the S3 bucket we have.
I didn't care.
User dynamo table dot grant read access read write data to the API lambda function. And similarly we have user upload S3 bucket dot grant public access or read write to the API lambda function. This is how you will specify you will give permission to this Lambda functions to read and write. And other than that, you can also add a policies, initial policies. So here we can just specify initial policy, and this policy, these are the policy statements you can add. This will be an array. Here you can add a resources like new CDK dot aws-iam. These are the IAM policies you are going to add to this Lambda, like adding a policy statements. And what policy statement contains, okay, what effect, there are 3 instructions, right? Effect, actions and resources. So cdk dot aws-iam dot effects allow, okay, we are doing allow for this particular actions and actions on S3. And the other thing is resources. I mean, either you can specify the ARN of S3 bucket, because on this S3 bucket I'm just writing a policy that you can do all the actions. So here you can specify, you have to specify the bucket ARN. Okay, so this is like you have added a policy statement with this Lambda. This Lambda can do the read, write and all the operations on this S3 bucket. Why it is complaining? Bucket ARN, okay, it should be an array. And similarly, you can attach a multiple policies. Here, let's say I'm talking about SNS. You can send this Lambda functions can send message to all the SNS queues which are there in this account. So if we don't know the topic, we don't know the ARN, then we can just specify wildcard. That means it can send to all the SNS resources. And then dynamodb. And we already have a dynamo table resource, user dynamo table dot ARN. Let's say dynamo table dot table ARN. So we will see if this works. I mean, we need to specify the table ARN for this. And I think, yeah, we will see, but because we also need to specify the index, all the access to the table resources. So this is how we can initialize the policies, like this Lambda can do this, do that, and then explicit permissions also added here to read and write to the S3 bucket and read and write to the dynamo table. And then you can also console output all the resources you are creating using CloudFormation output. So new cdk.cnf output, cloud function output. Okay, so what we are saying is this, and I'm just calling it as a, what is my API Lambda handler, API Lambda function. This is my resource, and I wanted to just set these output export variable names for the stack. So I can, when I want to refer, I can refer it from here, API Lambda function ARN, and the value is the ARN of the Lambda function. API Lambda function dot function ARN. So these are the export variables added to this particular stack. Similarly, we have a couple of more for the dynamo for the S3 bucket. So this is user dynamo table. I mean, these should be appropriate names. I'm just putting some random names for now. This should be table ARN, and then there is an S3 bucket. Dot, it should be bucket ARN. So these export names will be added, and we can also see that in the console that these are the resources has been created with these ARNs. So let's play with this. On to this source, we have index.js already, and that has a handler, index.handler. We may need to change our stuff in the Lambda. So handler is index.handler. Okay, so that should be good. And in the environment, you can populate, okay, S3 bucket name, DynamoDB table and all, whatever the environment variable you wanted to specify. Let's say I'm just specifying stage, and then I will just deploy this using CDK deploy. Now let's deploy this particular stack, which contains S3 bucket, DynamoDB table, and the simple Lambda function. So we will just do npm run CDK deploy, and we will see what all resources are getting created for this stack. API Lambda stack. Okay, creating the assets, and now if you see what all permission it is asking for, it is creating this particular role, and it is creating all these are the policies. Okay, resource, effect, actions, and principal, and then all the resources, like it is we are giving permissions for the S3 DynamoDB table and SNS, and it is creating these resources. And we can also see what all resources are getting created in the CloudFormation. So it is creating CloudFormation chain set and going to create all these resources for us. I mean, there may be a failure also if the resource already exists and you are trying to create it again, or you are creating some stack name which already exists or resource already exists. In that case, you may see a problem. You can see a DynamoDB table with identifier already exists. So it will roll back, it will not create anything. Can I add a policy here? Removal policy is cdk dot removal policy dot destroy, and here also I will just say destroy. So when I just do npm run cdk destroy, it should clean up both the resources like S3 bucket and the DynamoDB table. I mean, ideally we should not destroy them, because let's say somehow if you destroy a stack, your persistent like S3 bucket, RDS, DynamoDB table should also get destroyed. So we should avoid it. Here I'm just creating a demo and I'm just showing, because when I do this again, I'm getting this error because maybe a partially this stack was deployed and those resources were created and the stack was not completed. Now when I'm trying to create the stack, it is saying duplicate. So first let's clean up this stack by removing this S3 bucket and removing the table. Now I will just do is CDK deploy again. So it should create the resources again. So we are just doing simple plug and play with the AWS CDK and seeing how these resources are created, destroyed, what is the retention policy. So ideally now this should work. We should be able to see all the stack created with all these three constructs, which is DynamoDB table, S3 bucket, and a simple Lambda function. So it is creating CloudFormation chain set. Now what is this? API docs development already exists, because this S3 bucket already exists and we cannot create it again. So what I will do is I will just change this name. Ideally it should clean up the resources. Once we create these resources, we will do cdk destroy command to see if both these resources gets destroyed or not. You can see here I just now changed the resource names. So what it will do, it will automatically replace those resources with this. So that's also another way to clean up the resources. If you change the name, then the old resources, because now the stake definition has been changed. Now we are using a different S3 bucket with a different name. So the old S3 bucket, because the removal policy is destroy, will be destroyed. And similarly for the DynamoDB table. So it is creating this DynamoDB table, S3 bucket, and the roles, and creating this Lambda stack. And it will take some time because it is creating CloudFormation template and just then deploying that CloudFormation templates to the AWS. So here you can see the outputs. This API Lambda ARN, user DynamoDB table ARN, and user upload S3 bucket ARN. And we can also see all these resources in this stack. These are the resources. So you can see there is a S3 bucket, there is a S3 bucket, Dynamo table, and the Lambda function. And we can go to DynamoDB, Lambda, and S3 bucket to see all these things. So I can see one table there. I can see S3 bucket, and this is my Lambda function. Okay, you can see the sort key and the partition key, user ID and the created at, and this is my Lambda function. I'm still using simple JavaScript because for TypeScript I need to do the bundle and all these things will happen. This is my S3 bucket. Now what I will do is I will try to clean up the resources. Let's say if this removal policy really works, destroy. So what it should do is it should clean up the resources, means the DynamoDB table, Lambda, and this S3 bucket should be gone once we destroy this stack. So you can also see the progress in the CloudFormation, like whatever is we are doing through the CDK should be reflecting the same here. So delete is in the progress, and what all events, you can see it is deleting the resources also, so that's good. So it's deleting this S3 bucket. Delete complete. The only thing is the Dynamo table. The delete complete. So now if I just go and check the S3 bucket, I should not see that S3 bucket now. You can see that bucket is gone. User 1 docs app development. The Dynamo table is also gone. Okay. So that's a clean way of doing things, and to avoid any duplicates, because earlier we were facing some errors because the S3 bucket was already there. Maybe I did a Control-C while creating the resources, so the resources were partially complete, and then when I'm trying to do CDK deploy, the same name resources are already existing, because once you create once you do the CDK deploy, you can do CDK deploy 10 times. It won't complain that resource already exists, because that is part of the stack, and it won't create that resource again until unless you update the resource name or resource policy and all those things. So that's just a simple demo. Let's see, in the next video we will attach an API gateway to the Lambda function and see the real life example. Hi everyone, and welcome back. So in the previous video we were able to create a simple stack with S3 bucket, with a simple DynamoDB table and a simple Lambda function. Now we will introduce API gateway here, which is AWS API gateway. and we will see how it really works. So what we are doing is a Lambda cannot be triggered directly without API gateway. Okay, so this is our Lambda. There can be multiple Lambda functions. Okay, and for data storage we have a dynamo table. This is like we are talking about serverless stack. DynamoDB, and maybe we also have S3 bucket to store some content from some services. Okay, so how it really works is the request will come from the client that has to go through the API gateway. Now API gateway is like a simple construct we need to create. This API gateway can do couple of things. I mean, this is AWS API gateway, can do n number of things, but here we are talking about particular use cases. Either you can create a simple proxy so that whatever the request is coming from this API gateway, API v1 user, API v1 anything, will go to this Lambda. And we already know that in the current stack, we are current AWS CDK, whatever we are doing, we need to have API gateway with each and every Lambda, right? So this is our Lambda. We can simply do the proxy. What proxy will do is all the requests will directly go to the Lambda, and then Lambda can just do its stuff like writing to S3 bucket, reading from S3 bucket, or writing to the DynamoDB table. It's like a simple REST API. Right, these are the simple REST APIs we are exposing. Or what you can do is you can go in the old way. We are not creating a proxy. Here on the REST API gateway, what you will do, you will create a resources. Okay, the user, you will create a resources like user is a resource, and then you will create a methods like get, put, post. I will show you how it really works manually, and then we can also think about doing it. So this is, let's say, API gateway. We'll go to that console, API gateway. Here if you create a API gateway manually, okay, HTTP APIs, demo APIs. So here you can add a methods like for the integration request. This is the default name is the stage. That's fine. Create. So we are creating API gateway. Now on this API gateway, what you can do is you can create routes, resources, and all. I mean, this UI has little bit changed since I saw the last. So here, this is the get request, and this is the resource. You can specify here users. What you are doing is you are adding a get method to the user's resource. So you can see this is the get method. Now what you can do is you can attach a Lambda to it. So integration, I think it will be in the inside integration. Create and attach an integration to this. You can choose a Lambda function. Okay, now you might already have some Lambda function like this Lambda edge function, or currently we don't have any other Lambda function. And description, this UI had changed a little bit recently on the AWS API gateway, but this is how you are defining the mapping. Similarly, here if you go to the routes, this is the get function, but you can also create another function like, let's say, the post on the users. So what you are doing is you are not creating a new resource, you are just creating a new method. Similarly, let's say I'm just creating a put method on the users. So users is actually a resource, and these are the methods you are creating. So you can actually go manually and attach the integrations. Okay, for put, I have another Lambda. For get, I have another Lambda. For post, I have another Lambda. That's just a way in which we do create API gateways. Okay, I will just delete this one. We'll create our API gateway, or we just create a proxy, because in our case, what do we have? We have this actually this is actually a user microservice or auth microservice, because every service will have its own API gateway and the Lambda. So we just need to create a proxy. So whatever the request is coming, this API gateway will proxy to the Lambda, because Lambda cannot expose itself to the outside world. You need to attach an API gateway, and the API gateway we are going to have is just going to proxy, because this Lambda is not just a simple one single file, it's a whole Nest.js microservice which already has all the APIs in it. It's like a simple living HTTP server which has already all the APIs get put, post, and all the resources. So the API gateway will just do the proxy, and this Lambda will handle how to deal with the all the requests coming for different resources and different methods. That's just a one way. Another way is you define all the methods and all the resources at the API gateway and link individual small lambdas which are not coming with API gateway, each and every one. Let's say this is for HTTP GET, this is for HTTP PUT, this is for HTTP POST. So here we will be doing the request mapping with the different methods. That is just another way. So how we can achieve all those things? If you want to just create a simple proxy, what you will do is, I will just create a gateway, const API gateway equal to, and now here we will be just using the CDK construct, cdk.aws gateway, AWS API gateway dot lambda integration, and here you will pass the scope and your API gateway name. So the API gateway name can be simple as user API gateway, and you can also pass the stage, and then the next argument is, because here this is the proxy API gateway, so you have to pass all the arguments, like what is the handler, what happened, lambda REST API, it should be lambda REST API. Okay, now we can pass all the arguments. Handler is your lambda function which you created here, API lambda function, and deploy true. All the required arguments. Proxy, this is important because we are doing proxying, and then the MIME types for the API gateway, because API gateway is just going to proxy all the requests. So what we will say is whatever is coming except all the MIME types. And another option is the deploy options. We also want to pass the stage name. We already have a stage, so this will create just a proxy, and then we can just put it in the export names. This is user API gateway ARN. So here we are creating the API gateway. We can just print the API gateway bucket, API gateway REST API name, API gateway dot REST API name. Okay, and we just do is CDK deploy. I think stage is already populated. So here we just have created a proxy API gateway that will just take all the requests and take it to this lambda. Now this lambda function is doing nothing but just a simple, if you see the lambda function, it is just sending this simple message. but it can be a simple Nest.js service. And maybe I have already destroyed this stack, so I will be creating everything again. So it will be creating all the resources. That's a little bit time taking. Now next thing we are going to talk about is how we can do the mapping of individual resources with the different lambdas. Okay, it's not like we create a simple lambda. There can be a multiple lambdas and they will be attached to the different HTTP methods and the resources at the API gateway level. So here we can see that we created this API gateway and this is just doing only proxy, and you can see the integration. This proxy request is going to the lambda function, this lambda function. So this is what we created in the last video, and it is only talking about how we do the integrations. Okay, there can be a proxy integration with the API gateway, or you create these individual HTTP resources and build a REST APIs, like you build the resources on the API gateway, which we talked about. Like here you can just create a simple API gateway and then create the resources manually, that we have seen in the last video. Now what we are going to do, that we are going to automate it. We are going to create a simple REST APIs through the code. So I'm just going to take some helper example and try to create a simple REST API interface. Okay, so this is our simple stack. Okay, that is using dynamo table, simple lambda function, and this API gateway. Now we are not creating a proxy API gateway. What we are creating is, we just want to create a simple REST interface exposed through the API gateway itself, not through the lambda. So the lambda is just like simple functions. So I will try to just change it, lambda integration. So this will come from the AWS CDK dot, it will come from CDK dot AWS lambda, or it's come from AWS API gateway dot lambda integration, and here we need to pass the lambda function, API lambda function. Let's say this is API users, API get user lambda function. Okay, and we will just add the integration, and this we need to attach it to our resources. So the resources will be, here we are creating a proxy resources items, and we can call it as like a user resource, and we are adding a one method get to this get all integration, get all user integration. Just use some proper names so we will know. And there is a method post, and there can be another function we can create. I will just copy it for now. This is pointing to the same function. Here it is API get user, API post user. We need to change a couple of things. API maybe a get user, just do some changes. API post user, and also you need to change the lambda function, otherwise you get a conflict, right? API get user lambda, API post user lambda. So we will just create it as a API post user lambda, or better names is create user, update user, get user. So we will just add some permissions also, because we are using Dynamo and S3, so we can add permissions to this another lambda also. And then we will inspect the whole AWS resources, whatever we are creating. This REST API should be coming from API gateway, AWS gateway, dot REST API. So here, what is your users API name? It's like users APIs, and I can just put a stage here. This is my stage name. Okay, and this is the like resource I'm adding, users. So it will be HTTP users get, HTTP users post, and then there is another integration we need to create for the second lambda, which is post users integration, and here you just need to pass API post user lambda function, and then add this lambda integration to the function. And now we can also add cross origin resource sharing policies that we can skip for now, because sometimes when you do the integration with the front end, you need to send particular headers. You need to allow front end which is running on different endpoint or different port to communicate to the API gateway. So you need to send a cross origin resource sharing headers from this lambda so that they can talk. Now this is first lambda API first lambda ARN. This is, we are just exporting them as an output. API post user lambda ARN and function ARN. Okay. Now what we did is we have created this. We are creating this users resource on the API gateway, and where we are creating API gateway, here it will create an API gateway for all these resources you are creating. Here you can create n number of resources. I mean, I really don't do the in this particular times. We just use a lambda function having all the microservices in it. But if you want to do the mapping, when I say mapping, means we are actually creating these resources here. Okay, I'm using users, auth, cart, all these APIs, and then for each and every get put post method there will be individual lambda pointing to this. So users, this is simply you can say simply HTTP get. Right. So now another API is, let's say, the create user. It will be HTTP post. Resource name is still / users. This is resource name. And similarly there will be another lambda integration you will do. You will write lambda. So you can see the same thing we are doing in the code. We created a lambda, then we are creating a resource, and that resource, on that resource we are adding the methods, HTTP methods, get, put, post, delete, patch, and adding those lambdas to those particular methods. Because when I say HTTP get users, that particular lambda will hit. When I say HTTP post users, there will be another lambda which will be submitted. So this is REST API name is user service stage. Okay, now let's try to deploy it. We have REST API API.REST API name. I mean, we may see, because I didn't destroy this earlier stack, so because we changed a lot of names, the resource names, either because export names may also create a conflict. I will just create okay, so everything is same, stack name is same. Okay, let's see, do we need S3 bucket? So you can say user APIs upload, and for dynamo table API users table, let's say, okay, API get, these are the two lambda functions. And now what we need to do is simply CDK deploy. So what CDK deploy will see is we have two lambda functions, and these two lambda functions are simple, pointing to the same index handler. Okay, now we need to wait until this is done. I mean, it will take time because we are creating a lot of resources, API gateway resource, and then two Lambda functions, dynamo table. Also, I changed the name of the resource, so it will create a new dynamo table, similarly new S3 bucket, and then you can see all the progress happening on the AWS CloudFormation. It is creating the same stack. I mean, if the stack exists, and then it will delete the earlier resources because I changed the names. So what that means is, if those resources exist and I change the name here, the bucket name, then the earlier bucket name I'm not using, and the removal policy is destroy, so it will delete those resources. So you can see it's like going to take a lot of time, so we just need to wait and watch. Here we can see all the resources created. This is our API gateway. And this is simple Lambda function. This is API gateway. This is S3 bucket, dynamo table, API get function, API post user function. Now let's see this on the console. So here we can see two lambdas, post user, get user. And on the API gateway, I can see this API gateways. So the earlier API gateway might have been deleted because we replaced it. So this is now our API gateway, and you can see the resources. You can see the resources, get, and this is the integration request is going to the Lambda function, this Lambda function. Post is also going to the same Lambda function, right? You can see the integration is happening through the Lambda function, right? We have just a simple stage prod. So the API endpoints looks like this. You can see hello from my Lambda function. This is get request. So this is coming from our API gateway response, right? Okay, we don't have anything else, like we didn't create any API gateway models. It's just like simple resources we have created, and those resources are just hitting the Lambda, and that all happening through the AWS CDK. Apart from that, we also, let's check on the Lambda functions and their permissions, because we were attaching some policies to the Lambda functions, so that we can see configurations. Okay, you can see CloudWatch logs, it has an access to S3, SNS, and DynamoDB because we attach the policy, and you can see the role document. We allowed for S3 read and write anything, all the operations on this particular bucket, and for the SNS, for the DynamoDB, all the operations, right? And rest all are like creating the logs and all. Here you can individually see what you can do on the DynamoDB. These all operations you can perform on this particular table, on the S3 bucket, on SNS. I mean, you can access or any SNS topic, you can send it a message, and this is the CloudWatch logs because we added this policy. And you can also monitor and check the logs, what is happening with this particular Lambda. So we are sending a request. So when we send a request, it will generate the logs, and that it will generate the log stream, and that we can see. Okay, I'm not printing anything in the logs right now. I can just see if the logs are getting generated. Currently there is no much logs. So these are the role groups. Okay, so these are the logs created for the API post and API get. And the retention period is, you can see, 5 days. After 5 days, these logs will be gone. So it's a simple stack we have created through the AWS CDK. Now, the another important part is how we are managing the roles and permissions. Here we are doing a grant so that this Lambda, currently this Lambda is doing nothing. It's just like index.js. But when you write a microservice, whole zip file, you should be able to upload using this stack. Like instead of assets, simple file, you can upload a whole zip, and there will be a simple handler, a single function handler that will be bootstrapping your Express service or the Nest.js whole API system. Okay, so this is all about the API gateway. Now we will come to some of other topics of AWS CDK, and then we will jump back to the Uber Eats clone app. So let's see some simple examples. Let's say if I do CDK deploy, what will happen is I didn't change anything in the whole stack, so the deployment will be very fast. I didn't change any resource names. I'm not deleting anything. So it will just check, okay, it will just upload this code. Now you might just do some code update and just deploy. It will be ultra fast because it will generate the CloudFormation template and it will try to identify what is the change set. And if there is no particular change set, then the deployment is fast and it will give you all the resources. But let's say you are creating another Lambda, which is, I'm just naming it to API put users. So it's like a new Lambda we are creating, and I attached this resource to, this is API put, I guess. Yes. So I added a permissions and created an integration. Put user integration, and this is pointing to this Lambda. So I created a new Lambda and I will be adding that to this resource users put. So now it's really changed, right? So my Lambda function is API put user Lambda function. And I can just do a deploy, CDK deploy again. Now it can see, okay, there is a new Lambda you have added. So it will try to deploy this, because when it will try to find the change set, it will know, okay, you created a new Lambda with a new name. So it will add this resource on the API gateway, and it will also ask for the permission. Okay, this is what the resource it is creating, API put user, API put user. So it needs to give all the permissions, all the things which we are doing for the other Lambdas. And we can also see that the CloudFormation, what resources it is creating. That's important because here you can track everything, API Lambda stack, all the resources. You can see it has a table, it has a S3 bucket and 3 Lambda get put, and it is creating the other new Lambda. This is the stack info, and these are the outputs. You can see whatever the outputs we are generating, adding in the CloudFormation output, get user, post user, and now we will also see put user. It's like it's updating and creating the new resource. This is a